correlation. We have seen earlier when we studied scatter plots how they can be used to some extent to understand whether the association between two variables is positive or negative. The value of b that we calculated in the earlier section for the least squares regression line gives us a good idea whether the association is negative or positive, based on whether the gradient is negative or positive. But none give us a concrete idea about how strong this association really is. They do not tell us how well does our line of best fit actually fit our data. This is where Pearson's product moment correlation coefficient, R, comes to the rescue. Its value indicates the strength of the association. Its value lies in the closed interval -1 and 1. We can see the values of R for different kinds of association, ranging from R is equal to 1 for perfect positive correlation, R is equal to 0 for no correlation, and R is equal to -1 for perfect negative correlation. We can also see the scatter plots for intermediate values of R. The value of R, the correlation coefficient, is found using the following formula.
R equals summation of x minus x bar times y minus y bar all over n times sx times sy.
Where Sx is the standard deviation of the x values, Sy is the standard deviation of the y values, and n is the number of data points. Let us take our earlier example of marks in an exam and the number of hours of television watched on average per week. We add one more set of data for these learners, that is, the average daily time spent traveling to school in minutes. To understand the effect of hours of television watched in a week and the amount of time spent traveling to school daily on the marks scored, let us calculate the slope of the least squares regression line and the correlation coefficient for both sets of data. For hours of television watched and marks scored, we had calculated in the earlier section that b is equal to summation x minus x bar times y minus y bar all over summation x minus x bar the whole squared is equal to -4,581,2 over 1,808,4 is equal to -2,53. To calculate r, we need to calculate summation x minus x bar all over sx times y minus y bar all over sy. First, let us look at the tables as to how we calculate. Now,
R equals summation of x minus x bar times y minus y bar all over n times sx times sy
is equal to -0,996. For minutes of traveling and marks scored, we again calculate b and r as earlier. b is equal to summation x minus x bar times y minus y bar over summation x minus x bar the whole squared is equal to 958 over 4,502,5 is equal to 0,21. Now,
R equals summation of x minus x bar times y minus y bar all over n times sx times sy
is equal to 0,13. Let us understand what these values of b and r mean. For hours of television watched and marks scored, a negative slope of -2,53 indicates that the higher the number of hours that a learner has watched television in a week, the lower that his scores will be. The correlation coefficient value, -0,996, is very close to -1, confirming that this correlation is very strong. Hence, the number of hours spent watching television is a very good predictor for the marks scored. For minutes of traveling and marks scored, a positive slope of 0,21 indicates that as the amount of time that learner travels to school increases, the marks scored also increases. This seems non-intuitive. Let us look at the value of the correlation coefficient. The value of R, 0,13 in this case, is quite close to 0, which indicates that this linear association between time spent traveling to school and marks scored is very weak. Hence, time spent traveling to school is not a good predictor for the marks scored.
Need more help? Subscribe to our channel. Can't wait that long? Ask Masky to help you and let the math finally start mathing.